Hello guys, this is Airsoft Customs. Welcome back to our in-depth review of the T238 Brushless Motor. So let's keep it going. Okay, let's leave this aside until it cools down. Right now what we are going to do is take out the tower, properly sit. Oh, no. It has only one bearing and it's on top, but it's kind of big one. Let me see if I do have some other tower. Yeah. Please inspect this. This is the one from Warhead, and this is the one from, please ignore the fact that this is a smaller diameter, because I already modified that in order to make a new tower out of this. So just inspect the two bearings. This one is bigger, definitely better. Also the tower, if compared to a normal one, it's like normal tower from, let's see if this one is normal, because I modified pretty much all of them. No, this one is intact because it's totally new motor. This is what I was talking about. $8.99 versus 941, 942, something like that. This is the tower that should be used with the motors and not this stuff. First of all, it's bigger, it's wider, it can fit very well in pretty much every type of gearbox. Perhaps some of them it's going to be very tough to put this inside. However, it's going to be better to use wider or wide diameter here, because you don't want your motor to play sideways, upside down and whatever while you're making the shimming. So let's see what else do we have inside. We will wait our soldering iron to get the right temperature, and we will try to desolder this. I will pop up the capacitor just because I will need to desolder this piece right here. Let me see if I can zoom actually, because yeah. So I will need to pop up the capacitor in order to get to this soldering point. We have three faces, so we need to desolder them just as a regular Warhead motor. We are ready to pop it out. Let's see what do we have here. On this motor we have this, and the controller, actually the halo sensors. Whoa, this is this is so strange. We also have those here. Those are the controllers, ones versus the others. Come on, goddammit, focus. On the left it's the Warhead, and on the right it's the T238. What else we can see? I don't know how to say this, guys, but this is very strange. I really don't know what I'm seeing right now, because it's definitely different than what we have in Warhead motors. But now I can clearly see why torque wise this motor needs a lot more force to be turned. But let's take it out. Let's take out the rotor. Oh my god. This is totally different. Who would expect this? Maybe I will be able to shim it better than what they had, because there is a small bushing here which just pops out. God damn it, this is so interesting. Let's clean out the mess and I'll come back again. Okay, we cleaned the table a little bit so we can actually measure and check what are the differences in between the Warhead and the T238 brushless motor. We already explained that they have a nice tower, or better made tower. This is the best tower that I actually see on any motor, doesn't matter if it's brushless or brushed. We have the boards itself, they are pretty different. This one, it's like 1.17, or actually let me just see here, 1.18 thicker, when the T238 uses a lot more thicker board, like, come on, goddammit, 1.65. What else is different? Yeah, generally everything is different on the board except the shape. Generally it's the same. They use the same 6 pins. Actually here are 6 pins, but here are 4 pins. They use a configuration of some, I need to check those FETs, how they are, if they are stronger or not. Later we need to clean the board so we can solder it again. Soldering job here, it's definitely better than on the T238, but again, Warhead, it's a project that costs a lot of money, so it's generally understandable why it's so different. The tabs, you can notice how good they are here on the T238 and how bad they are on the Warhead. Those are repaired ones. I repaired them, and I never use the board because I decided to use the entire motor as a spare part. I do have another boards which are totally new from the Warhead, but I decided not to use them because I will need someday to have all of those fats intact so I can desolder and solder again on any other board that I can find that customer throws me. So I don't know, guys, I don't know what to say, but definitely this is a nice looking board. This is pretty much all of the I can think or I can see on the board itself. It's very well made. I can't see anything misplaced on the top part, where on the back part, yeah, they are kinda torched some direction, but anyway, they are pretty much on spot. But those tabs, take a look, this is massive. You will break the board, but this will never break for sure. So kudos to T238, they made a great job. I don't know why Warhead didn't use those. It's such a waste of time to rebuild this shit with new cables. I mean, to put the cables like the Ronin ones from here and take them out, you have to cut your original cables so you can use the Ronin or any other motor that have directly cables on it. I think it's a stupid idea. I already tried it even before Warhead, even before they made it, so I don't think it's a good idea. Anyway, they can state what they want, but generally they simply need to use thicker ones. They are rock solid, even without any glue, like the ones that I received in the new batch. Anyway, let's proceed further. This is a stock rotor of a Warhead. It has 4 magnets. The dimensions of it are exactly, come on, not there, 74.14. This is the rotor of the T238. I can definitely see thicker magnets. Their surface is not so wide as those. I don't know the shape of them because I need to screw the whole axle, the whole rotor, if I want to check them internally. But those are very, very strong magnets. They are wrapped with stainless steel tubing, and they have a lot more force than the Warhead. So this is the dimension of the T238, 75.25, 1 millimeter and 1.1 millimeter actually, to be pretty much exact. They use smaller bushing in the back just to compensate the different shapes and dimensions here and here. So what else is different, because we started in that direction? As you can see, we have here on the rotor 11.87. Where the magnet sits is actually 11.14. 11 point what, 11.27, but 11.88 it's the rotor itself, and 11.29, 26 is the diameter of the magnets. Let's see what do we have inside of the stator. Stator diameter internally, it is actually 12.53. 12.53. So we have a gap of around 7/10 of a millimeter. Let's see this one. Outside it's 12 point something, 12.3. Inside where the magnet sits, it's 11.44. If it was to put directly this inside of a Warhead, this was going to be a lot more shimmed to the armature of this one, because the rotor of the T238, it's wider than the Warhead one, and it was going to fit perfectly inside of a Warhead. This is one of the points that I see the T238 going better, definitely way better than the Warhead. And to conclude that exactly, we will measure the T238 stator. So it is 12.54. 12.54 versus 12.55. Well, it seems that they have pretty much identical dimensions, internal dimensions of the stator. So the only thing that changes are the rotors by themselves and their dimensions. The T238 rotor has been made a lot more wider, a lot more, it's some tenths of a millimeter, but as you may know, this is pretty important because magnets need to be sit pretty close to the armature so they could interact magnetically, and this is why I definitely believe that the T238 has done a better job here. I don't know, guys, but for me this configuration, it's better than the one that Warhead provides. It's only my thought, don't get me wrong, it's just my thought, my 2 cents of what I'm seeing, what I'm checking with the caliper, and what I'm generally inspecting. The motor is already assembled, and we would like to test the adjustability of the potentiometer. So right now it's OEM, I mean out of the box. Yeah, it's definitely great. Let's turn out the small wheel at the back. To be honest, it's not a good idea to turn it from here. The best will be to open up and turn it there. So, as you can see, this is definitely a working adjustability. Let's see if it can go down a lot more. Can go down, but the problem is that if you adjust this from here, you have a problem, because the small potentiometer, it's not so how to say, it doesn't have, it's it's kind of soft. It's made of soft material, which if you don't be precise, if you're not precise, you will definitely waste the shape of the flat screwdriver. This is happening just right now, and I wanted to show you because there is a small drawback, yeah, and you will find it someday if you buy this motor. And I want to be honest with all of you, and also with T238, because this is a great idea, but you need to pay special attention to it, because it will lose the shape and lose the controllability. So we was at 1.40 something amps, and there is still place to turn more, like that, or even more, yeah, like that, and this will bring it down to 1.3 amps, and it will turn a lot slower. But for the moment, because I really don't want to mess more with it, I will left it where it was. Yeah, right. Yeah, I think I maybe screw it. Let me just see. Okay, so positive was here and negative was right here. Yeah, I lose some of the speed, and I will see if I will be able to put it right where it was. Sorry, I didn't focus. Let me just show you again. Look at the reading, the amp. So this is not the OEM speed. I bring it down just a little, and I need to try to get it to work where it was, because this is a very small potentiometer. I don't know if I'm going to be able, because it's already melted from my screwdriver and from me trying to push from this small hole. This small hole, it's actually limiting your tools, and your tools need to be long and sharp, and a tight diameter in order to get to fit right here. So one thing to mention to the T238 is okay, you put this small potentiometer here, and you made an adjustment hole. Please make it bigger. You can make it any shape. It doesn't need to be a circle one or a normal hole. It can be, I don't know, any shape you want. Just to be clear that if somebody is going to adjust the motor speed, this is a good feature. It has enough space to put his screwdriver and make this adjustment, and not try to do it several times, because this is what it happens. It goes to, I don't know, it just turns out bad, let's say it that way. When I checked the whole content after I made this video, I wasn't sure what to post and what to practically hide or fast forward. But I decided to actually show you what can happen if you don't pay attention, or if the motor cap it's a little bit misaligned to the hole. I mean, the motor cap is misaligned to the motor, and it is misaligning the hole to the potentiometer. So this is what it can happen. Yeah, it's not good, but again, this is a testing unit, so I don't really care if it's going to be 25k, 30k or 33,000k. As long as it's working, it's good for any usage, any testing or whatsoever. But let's assemble it and test it in a gun. Well guys, it's been a long video, so it is all from us right now. We will see you on the next one.